Hello guys, welcome to H2O, the A to Z of chemistry. I'm Dr. Ritu Johar, your educator for this course on hydrogen, and I hope you are enjoying this course with me. So today we begin with lecture 14 from the course, but make sure you watch the previous ones before doing this one. And in fact, this is going to be the last lecture from this course. We have already discussed about hydrogen, the hydrides, then we had a detailed discussion on water. And in lecture number 12, we started the discussion on hydrogen peroxide. And also in lecture number 12, what we have discussed is the structure and the preparation of hydrogen peroxide. And in lecture number 13, we have discussed the strength of hydrogen peroxide, where you learned a very important term related to the strength of hydrogen peroxide, that is volume strength. Right. So now moving on further in this lecture, where we will be winding up with the discussion on hydrogen peroxide, we will be discussing about the properties of hydrogen peroxide, that is the physical as well as the chemical properties. And then we will be discussing some tests related to hydrogen peroxide, and finally the uses of hydrogen peroxide by the study of hydrogen peroxide. This is so important for us. So the first thing that we will be discussing in today's lecture is going to be the physical properties of hydrogen peroxide, and the first is that pure hydrogen peroxide, this is almost colorless or a very pale blue colored liquid. Now I've never seen this very pale blue color of hydrogen peroxide. I've always seen it to be a colorless liquid. I'm a dental surgeon and we use a lot of hydrogen peroxide in our practice, be it for various surgeries, root canal treatments, and one thing that can interest you people is the whitening of teeth. So we use hydrogen peroxide in the whitening of teeth, but you yourself are never going to do that. Okay, so please do go to a dental surgeon if you require whitening of teeth, right? So pure hydrogen peroxide, this is almost colorless or a very pale blue colored liquid. Now the next we have is that this is more viscous than water, and its density, this is about 1.44 gram per centimeter cube, whereas that of water is, I hope you all remember, at 4 degrees Celsius it is 1 gram per centimeter cube. So you have learnt it in this lecture, this course only, so you should remember this, right? So the density is going to be more than that of water. It is miscible with water, alcohol and ether in all proportions. So whatever may be the percentage of water or hydrogen peroxide, they are going to mix with each other, and similar will be with alcohol and ether as well. The next is that it can form a hydrate with water. So this is going to be H2O2 dot H2O. Its aqueous solution, this has a bitter taste, so please do not try tasting it. And the melting point is 272.4 Kelvin. So this is slightly less than that of water. And the boiling point, this is about 150 kelvins greater than that of water. It is 423 Kelvin. And the reason that it has a higher boiling point than water is because of more hydrogen bonding which can occur in hydrogen peroxide. Okay. So next we move on to the chemical properties of hydrogen peroxide, and these are going to be very important for you people because lot many questions coming in the examination. So the first property is the decomposition reaction. Decomposition, breaking down of the composition into the constituent substances, right? So pure H2O2, this is unstable and decomposes into water and oxygen either on heating or on long standing. And the reaction is something that you've already seen in the last lecture while we were discussing the strength of hydrogen peroxide, right? So 2H2O2 on heating or on long standing, this is going to form 2 moles of water and 1 mole of oxygen, and the lot of energy is released in the reaction. So this is an exothermic reaction. Now we will rewrite this reaction in another way. The 2 moles, we have written it now separately. And now what I want you to is find out the oxidation number of the oxygen atoms in hydrogen peroxide, water and oxygen. So in hydrogen peroxide, the oxidation number is going to be -1. In water it is -2, and in oxygen, this is the elemental form, so the oxidation number will be 0, right? So look at this. From -1 in hydrogen peroxide to -2 in water, this is a decrease in the oxidation number, so the reaction is a reduction reaction. And this molecule, if you see, from -1 to H2O2 to O2, we have an oxidation number of 0. So this is an increase in oxidation number. So this is going to be an oxidation reaction. So oxygen is going to be having an increase in oxidation number as well as a decrease in oxidation number. So simultaneously the same element is undergoing a reduction as well as oxidation. So such a reaction in which the same element is getting oxidized as well as reduced, this is called as a disproportionation reaction. So this is one thing that you have to remember. Now, this decomposition, this is catalyzed by a lot many things. Okay, so the breakdown of hydrogen peroxide, this can be occurring in the presence of lot many things. For example, the transition elements, most of them, for example, finely divided platinum, silver, they can increase the decomposition of hydrogen peroxide, right? Similarly, the transition metal compounds like manganese oxide, this can also increase the decomposition of H2O2. Carbon particles, dust particles, light, alkalis, rough surfaces, they all catalyze the decomposition reaction. Okay. So one thing that we have discussed is that we do not keep, while we were discussing in lecture number 12, the storage of hydrogen peroxide. If you remember, we said that we do not store hydrogen peroxide in uh, transparent bottles. We store it in light dark colored bottles because light, this can catalyze the decomposition of hydrogen peroxide, right? Similarly, we do not keep it in glass bottles because glass bottles, this has metals into it which can increase the decomposition of hydrogen peroxide, and also the rough surface you be avoided by wax lining, right? So this was what we discussed in this storage of hydrogen peroxide as well. Now, one thing more which you have to remember is that in the NCERT textbook, I'll just read out the line to you, that in the NCERT textbook, it is given that uh, it should be kept away from dust because dust, this can induce the explosive decomposition of the compound, right? So we have to keep it away from dust. Now what this line means is that it is actually not the dust particles which are causing an explosive reaction. What the dust particles here mean, they are going to be the coal particles, or you can say the carbon particles, because the reaction, decomposition reaction, this is going to produce oxygen. So oxygen, this can react with coal particles or carbon particles, and that is going to be something which can cause an explosion. Okay, so this is something that you will remember, fine. And also now, if you want to avoid this decomposition, we can add certain things into the hydrogen peroxide solution. For example, we can add acetanilide, glycol. These are going to be the retarders or inhibitors of the decomposition reaction. Okay, so this is everything that you have to remember for the decomposition reaction. So the next property is the acidic nature of hydrogen peroxide. Anhydrous hydrogen peroxide, this is weakly acidic in solution, and because it is acidic in solution, so this means that it can react with bases to form salts, and because it is weakly acidic, it is going to ionize slightly in water. So H2O2 plus water, this will be forming hydronium ion, that is H3O positive, and HO2 negative ion, this is the hydroperoxide ion, right? And then this HO2 negative, on further reaction with water, this can form H3O positive and O2 negative, which is the peroxide ion. So one reaction which you can learn for the bases as well is that it will be forming just similarly the reaction with the bases also, and it will be forming two series of salts. For example, now instead of water, if I write NaOH over here, so H2O2 plus NaOH will be forming water plus NaHO2. So that will be sodium hydroperoxide. So this is negative part. Na would be the cation for it. So NaHO2 and NaHO2, this will be reacting with water to form Na2O2 and water. So the total reaction, because the peroxides, they are the more important salts, so the total net reaction, you can write it as 2NaOH plus H2O2. This will be forming sodium peroxide and water. So we can use hydrogen peroxide for preparing more of the peroxide salts also, right? Similarly, sodium carbonate, this on reaction with H2O2, this will be forming sodium peroxide, water and carbon dioxide gas, this will be evolved, okay? Now, one very important thing which I want you to just look back while we discuss the hydrogen peroxide decomposition reaction, and that is H2O2 forming what? Forming water and oxygen, right? So here I just told you just now what was the oxidation number of oxygen in all the three. I've just not written the complete balanced reaction. I just want the oxidation number. So in oxygen it is 0, in water it is -2, and in hydrogen peroxide this is -1. Now when hydrogen peroxide this gets converted into water, it is going to be a reduction in the oxidation number. So this is what? This is a reduction reaction. And when it is going to be an increase in oxidation number, this is an oxidation reaction. So it is getting converted into oxygen. So what this means is that hydrogen peroxide, this has a potential to decrease its oxidation number and increase in oxidation number. So this has a potential to get reduced as well as it has a potential to get oxidized. So when it is going to combine with various substances, it is either going to act as an oxidizing agent or it is going to act as a reducing agent depending upon the substance, whether it is going to get oxidized or it is going to get reduced, and also on the media in which it is going to be reacting. Okay, so what we will be seeing is that hydrogen peroxide, this can act as a reducing agent as well as an oxidizing agent, and it can act as a reducing agent as well as oxidizing agent in acidic media as well as in basic media. Please do remember this because this has come many times in the examination, that hydrogen peroxide, this acts as an oxidizing agent as well as a reducing agent both in acidic media as well as in basic media. So I will be giving you now all the details related to that, but this is something that you have to remember. Fine. So first we will be discussing the oxidizing properties. So hydrogen peroxide, this acts as an oxidizing agent in both acidic as well as basic media and even in a neutral media. Okay, so let us see all these reactions. First we will see the reactions in neutral medium. So here we do not add either a acid or a base. It is just the reaction with the compound where hydrogen peroxide, this is getting decomposed to give nascent oxygen according to the reaction H2O2, decomposing to form water, and a nascent oxygen is getting released. This nascent oxygen, this has a potential to oxidize the substances. Alright. So for example, we have oxidation of lead sulfide to PbSO4. So here if you look at the oxidation number of sulfur in PbS, this will be -2, and in PbSO4 it will be +6. So I hope you all know how to calculate the oxidation number. So this is -2 to +6. Right? So this is an increase in oxidation number. So this is an oxidation reaction. And who is causing that oxidation? It is going to be H2O2. So let us look at the reaction. PbS plus 4H2O2, this will be forming PbSO4 plus 4H2O. Right? So this is the reaction in which hydrogen peroxide, this is acting as a oxidizing agent. I hope this is clear. This is a very important reaction. This is an important reaction because this has a very important application as well. And what is that application? The application is that if we have lead paintings, okay, so if we have lead paintings, the color of the lead paintings, original color is white in color, right? But when it is on the wall for some time, it is going to react with some amount of traces of hydrogen peroxide which can be present in the atmosphere, and when lead reacts with H2S, it forms lead sulfide and hydrogen. Okay, and this lead sulfide, this is blackish in color, so the color of the painting, this is going to get blackened, but we are not going to like that painting. Okay, so what you want is you want to restore the originality of the painting. So what we do is we dip it in a very dilute solution of hydrogen peroxide, and when we do that, it is going to oxidize PbS to PbSO4, and PbSO4 is going to be again white in color, so we will be getting the white color of the old lead painting restored. So this is something very important, very frequently asked in the examination, so you should remember this. Alright. Now, when we are seeing this reactions in the neutral media, you can see that it is an oxidation reaction. So sulfur, this has a oxidation number ranging from -2 to +6, right? So this is the lowermost number of oxidation that sulfur can have. So obviously when it is going to react with H2O2, which has a tendency either to oxidize or reduce, so sulfur, this is going to get oxidized. Okay. So if a substance is going to have a highest oxidation number, then that is going to react with hydrogen peroxide. Its oxidation number will get reduced. Okay. So when it is in the lowermost oxidation number, it is going to get oxidized in the presence of hydrogen peroxide. The oxidation number will increase. I hope this is clear. Fine. So next we have is the oxidation of sulfides to sulfates and nitrites to nitrates. For example, when H2O2 this reacts with sodium sulfide, it will be forming sodium sulfate, and when it is going to react with sodium nitrite, it will be forming sodium nitrate. Okay, so this is the oxidation of sulfides to sulfates and nitrites to nitrates. So this is one example. It can be any other metallic sulfate or sulfide or nitrite. Okay. So remember, it is just as sulfides to sulfates and nitrites to nitrates. The next, it can also oxidize arsenides to arsenates. For example, sodium arsenide to sodium arsenate. Next, a very important reaction in the acidic medium. It oxidizes cold acidified potassium dichromate solution containing ether to chromium pentoxide. Alright, so H2O2, this reacts with K2Cr2O7, that is potassium dichromate, in presence of an acid to form potassium sulfate. So potassium reacting with sulfate to form potassium sulfate. Chromium, this forms chromium pentoxide. The structure of this chromium pentoxide, this is very important. Alright, I'll just come to that, and along with this water molecules, they are going to be formed in this reaction. And one thing that you have to remember is that this reaction is happening in the acidic medium, and the temperature that is going to be is ice cold. Okay, this is going to be very, very important, right? Because you're going to see one more reaction, and in that reaction, the temperature is going to be a normal temperature, and the product that is going to be formed is going to be different. Alright, now chromium pentoxide, as I told you, this is a peroxide with a butterfly-like structure. So you can see chromium in the center. There are two peroxide linkages present in this molecule, and this is a butterfly. So chromium, this is the head of the butterfly, and these are the two wings of the butterfly. So this is a very important structure which is asked in the examination very frequently, and this is something that you have to remember very well. Alright, the next reaction where we see the oxidizing character of H2O2, this is in the oxidation of mercury to mercuric oxide. So H2O2 plus mercury in presence of dilute H2SO4, this is going to form HgO, that is mercuric oxide plus water. The next we move on to the basic medium. So in the basic medium H2O2, this can accept electrons, and thus also it is going to act as an oxidizing agent. So anyways, it is going to accept electrons, it is getting reduced, and it is acting as an oxidizing agent. So H2O2 plus OH ions plus gain of 2 electrons, this is forming 3 OH ions. So in total, the reaction is going to be H2O2 plus 2 electrons forming 2 OH ions. But what you have to remember is that this is the actual reaction that is happening. So it is going to use OH ions, and yes, ultimately it is forming more OH ions. Okay, I hope you remember this. So the next we have the examples in the basic medium. So this oxidizes manganese sulfate to manganese dioxide, MnSO4 plus H2O2 plus NaOH forming MnO2, Na2SO4 and water, right? So sodium is combining with the sulfate to form sodium sulfate, manganese going up to manganese dioxide, and H2O2, this gets reduced to water. Fine. Next, if we just write it in the ionic form, how are we going to write it? Mn plus 2 plus H2O2 plus 2 OH ions forming MnO2 plus 2 water. Another very important reaction in the basic medium which you have to remember is that this oxidizes formaldehyde to formic acid in presence of pyrogalol and an alkali. So this is 2HCHO, this is formaldehyde, plus hydrogen peroxide in presence of pyrogalol and an alkali forming formic acid. So this is an oxidation reaction of an aldehyde into a acid, and along with this hydrogen is produced, and along with this light is produced. So this is very important. So this reaction of H2O2, this occurs in dark, and this is associated with emission of light, and this phenomenon, this is called as chemiluminescence. So this chemiluminescence, this is used in various fields of medical science like cancer cell markers, DNA sequencing, in gas analysis to check air pollution, forensic science to solve cases by detectives, etc. So this is a very important reaction, and here also do remember what is the structure of this pyrogalol. So pyrogalol, this is benzene 1,2,3-triol. The structure is over here. So this is benzene. Position number 1, 2 and 3 occupied by 3 OH groups. So this is benzene 1,2,3-triol, and this is a very good absorber of oxygen. Next, moving on to a few more properties. So this oxidizes chromic salts to chromates. So chromium plus 3 plus 3H2O2 plus OH ions forming chromate ions plus water. For example, we have chromium sulfate plus H2O2 plus NaOH forming sodium chromate plus NaSO4, and again water is going to be formed. This oxidizes benzene to phenol. So benzene plus H2O2, this is going to form in presence of FeSO4 phenol, that is OH group. This gets added onto the benzene ring. So now in all these reactions that you have seen, all the oxidizing reactions, hydrogen peroxide itself is getting reduced to either water or OH ions. So this is something that you have to remember very importantly. In your examination, many of the questions, what will you see is that there are going to be 3-4 choices in which the reactions will be given to you. There may be reactions that you have seen in these slides, but there may be other reactions also where hydrogen peroxide is going to act as an oxidizing agent or a reducing agent. These are not all the reactions, and these are much more than the reactions which are given in the NCERT textbook. So you have to just see these reactions. You have to remember the reactions which as much as you can. But in case you forget them in the examination also, please do remember in all the oxidizing reactions, H2O2, this is going to get reduced either to water or OH ions. So you will be seeing in the product size water being formed or OH ions being formed. For example, KOH is being formed, right? So you have to remember this. And the oxidation state of oxygen in all these reactions is going to change from -1 in H2O2 to -2 in water or OH ions. Perfectly fine. Now let us move on to the reduction reactions. Okay, before that, there is one important thing which I forgot to tell you, that the oxidizing property of hydrogen peroxide, this is very important to us because this kills the germs and it also inhibits the growth of microorganisms like bacteria, viruses, etc. and this spreads the spread of any infection. This property, this is utilized in pollution control. All right, and this property that you can use to disinfect your tabletops. For example, you can disinfect your kitchen counters with this use of hydrogen peroxide. So all these are because of the oxidizing properties of hydrogen peroxide. Next, moving on to the reducing nature now. So H2O2, this exhibits a reducing nature because of its tendency to take up oxygen and from the strong oxidizing agents. So oxidizing agents which are going to be stronger than H2O2, H2O2 is going to take an oxygen from them, form water and oxygen. So now what you will be seeing in the reduction reactions is that oxygen will be evolved. In the oxidation reactions, what you saw was that either water was being produced or OH ions were being produced. But now in the reduction reactions, always you will be seeing that oxygen will be evolved. So this is one thing that is going to help you identify what are the oxidation reactions of H2O2 and what are the reduction reactions of H2O2 by just looking at the reaction. You don't have to find even the oxidation number for them. Okay. Okay, so please do remember this. So let us see now the reduction reactions in the neutral, acidic as well as the basic medium. So in the neutral media, this reduces halogens to halogen acids, chlorine plus H2O2 forming HCl and O2. Right? This reduces metal oxides to metals. So Ag2O plus H2O2. This is going to form silver plus water plus oxygen. PbO2 with the reaction with water, this will be forming PbO plus H2O plus O2. So you're seeing in all these reactions that O2 is getting evolved. Reduces oxygen to ozone, so O3 plus H2O2. This is forming O2 plus water. Now, one very important thing related to this reaction, that this reacts with chlorine, right? It is going to utilize this chlorine and form HCl, and oxygen will be evolved, and therefore this is called as anti-chlor. Okay, anti-chlor, anti to the chlorine that may be present. So it is used on bleeding wounds as it destroys the unreacted chlorine. In the acidic medium now, let us see the reaction. So H2O2, this is going to donate electrons and act as a reducing agent. So now what are we going to see? In the oxidation reactions, what you saw was that H2O2, this was gaining electrons. Now in the reduction reactions, it is going to lose electrons, and again the number of electrons lost is 2. So the Z factor is going to be 2 for H2O2. Right, so this is one thing that you have to remember. And now let us see the reactions. So this reduces potassium permanganate, 2 sulfates of potassium and manganese, rendering the reactants colorless. So 2KMnO4 plus H2SO4 forming plus H2O2. This is going to form potassium sulfate. So K reacting with sulfur to form potassium sulfate, manganese reacting with sulfate to form manganese sulfate, and the rest is going to be water and oxygen that is going to be formed, and the pink color of potassium permanganate is going to be rendered colorless because of the formation of manganese sulfate. And this is a question which has been asked in the AIMS examination. I do not remember the year, probably 2004, in which you were asked that how many moles of H2O2 they are required to render potassium permanganate colorless. So this is going to be for 1 mole of KMnO4, 5/2 moles of H2O2 will be required. Okay. So this is one question that has been asked, so I just remember it. Alright. Now this reduces potassium dichromate orange, 2 sulfates of potassium and chromium green. So this is K2Cr2O7 plus H2SO4 plus H2O2. Now the temperature is different over here. So you have seen the oxidizing properties. Now you are seeing the reduction properties. In the oxidizing properties, we saw oxidation of K2Cr2O7 to chromium pentoxide, right? But that was, the temperature was ice cold. Now the temperature is going to be ordinary room temperature, where we will be seeing that potassium dichromate in presence of an acidic medium is going to react with H2O2, and the color of the potassium dichromate, which is orange, this is going to change to green, and this is green because of the formation of chromic sulfate, right? So K forming sulfate, chromium forming its sulfate, plus along with that water and oxygen. So in all the reactions, either it is going to be in the neutral media, either it is going to be in the acidic media, or it isn't going to be in the basic medium. You will see in all the reactions, oxygen is going to be liberated. So next, let us see the reactions in the basic medium as well. So H2O2 in presence of the OH ions of the basic medium. This is going to form water, oxygen, again a loss of 2 electrons. A loss of 2 electrons, again the Z factor is going to be 2. So either it is the oxidizing properties or it is the reduction properties. Either it is the acidic medium or it is the basic medium. You are seeing that there is a gain or a loss of 2 electrons. The Z factor is always going to be 2 for H2O2. Okay, so let us see the reactions as well. So this reduces potassium ferricyanide to potassium ferrocyanide in presence of the basic medium. So you have seen in the acidic medium, H2O2 was reacting with potassium ferrocyanide to form potassium ferricyanide. Now in the presence of OH ions, it is the opposite reaction that is happening, right? The next we have is potassium permanganate. This is reduced to potassium manganate. KMnO4 plus KOH plus H2O2 forming K2MnO4 plus water plus oxygen. So in all the reactions, what you have to remember, even if you forget the reactions, is that in all the reduction reactions, H2O2, this is going to get oxidized to either oxygen, sorry, it is going to get oxidized to oxygen, and the oxidation state of oxygen, this is going to get converted from -1 to 0. In the oxidation reactions, H2O2 will either get oxidized to water or OH ions, and the oxidation state is going to change from -1 to -2. So just remember this always. This is going to be really helpful in your questions that are going to come in the examination. The next we have is the bleaching action. So H2O2 is going to decompose to form water, and a nascent oxygen is going to be released, and this nascent oxygen, when it is going to combine with a coloring matter, this is going to render it colorless, and this is a property that we use for the bleaching of clothes, for the bleaching of silk, for the bleaching of wool, and very importantly, which interests the girls the maximum, that they can color their hair also, discolor their, actually bleach their colors here with H2O2, and that is going to look like golden streaks. Okay, so I hope you will remember this. The bleaching action of hydrogen peroxide is because of the release of this nascent oxygen, which is going to combine with the coloring matter. Next are the addition reactions. So for example, we have ethene. It is consisting of an unsaturation, a double bond is present. So here H2O2, this is going to add up, there is going to be breaking of the double bond, and we will be getting CH2OH, CH2OH. So this is called as ethylene glycol. So as far as the reactions they are concerned, this is it. Let us see the tests for hydrogen peroxide. So as far as the tests for hydrogen peroxide they are concerned, these are the tests that we use generally to check for the presence of hydrogen peroxide in the laboratory. So the first is that this liberates iodine from the potassium iodide solution. The reaction you've already seen in the chemical properties. So this iodine which is going to be liberated, now this can react with the starch solution to give it a blue color. So the blue color of the starch solution, this is going to confirm the presence of hydrogen peroxide, right? So first, what are we going to do? We are going to take a Ki solution, add to this H2O2, and we are going to react it with starch solution. So this is what we will be getting, a blue color. It decolorizes the acidified KMnO4 solution, which is pink in color. So this is going to be pink to colorless by the formation of manganese sulfate. So again, the reactions you have seen in the properties. So all the reactions where you were seeing a color change in the reactants to the products, they all can be used for the tests for hydrogen peroxide. One reaction which we have not done previously is that this gives yellow or orange color with titanium sulfate solution due to the formation of pertitanic acid. So titanium ions plus H2O2 plus water, this is going to form H2TiO4, that is pertitanic acid, which has a yellow or orange color, and this is also going to confirm the presence of hydrogen peroxide. So the last slide for this lecture that we are going to have a learning for this lecture as well as for this course also, because with this we are going to wind up with the course on hydrogen as well. So the uses of hydrogen peroxide, in fact the uses is something that we've already discussed while we were talking about the chemical and the physical properties of hydrogen peroxide. So let us quickly look at few of the uses now once again. So dilute solution of H2O2, this is called as perhydrol. I hope you all remember that it is going to be a 30% solution or a 100 volume H2O2 that we call as perhydrol. So we use this as an antiseptic for cleaning wounds, ear and teeth, and one more use which I told you for the teeth was that we can use it for the whitening of teeth. Right. Next, it is used as an anti-chlor in the textile industry to remove excess of chlorine from the cloth, and also it is used as a bleaching agent in the textile industry. It is used for the bleaching of wool, for silk and for hair. That is what we have already discussed. So it is used to manufacture chemicals like sodium perborate, sodium percarbonate. You need not know the reactions for that. And these sodium perborate and sodium percarbonate, they are used in high quality detergents. This is used in the synthesis of many medicines and food products, for example, hydroquinone, tartaric acid and certain other food products and pharmaceutical products. So this is important to us in the food industry as well as in the pharmaceutical industry. It is used in the environmental chemistry or the green chemistry. This is used for pollution control. What is the for the pollution control? It is going to be used for the treatment of the domestic and industrial effluents. It is going to be used for the treatment of the sewage which is coming from the homes as well as from the industries also, and this is going to cause a oxidation of cyanides, restoration of the aerobic conditions to the sewage waste, etc. So very important in the maintenance of the environmental chemistry, right? So these are a few uses. Some of the uses we've already discussed while we were talking about the chemical properties. So combine all of them and you will be getting a complete list of the uses of hydrogen peroxide, a very, very important compound for us. So now let us look at a few questions from this lecture. Today's lecture, there are going to be not 5 questions for the lecture review questions. There are going to be 8 questions, and these are because many questions they are coming in the previous year examination from this topic. So the first question is, from the following choose the incorrect statement about hydrogen peroxide. The first choice is it can act as an oxidizing agent. It decomposes on exposure to light. It has to be stored in plastic or wax lined bottles in the dark. It has to be kept away from dark, and this is a question which has been asked in the JEE Mains 2015 examination. The next is the chemical nature of hydrogen peroxide is oxidizing agent in acidic medium but not in basic medium, reducing agent in basic medium but not in acidic medium, oxidizing and reducing agent in acidic medium but not in basic medium, oxidizing and reducing agent in both acidic and basic medium. So this should be now a very easy question for you, and this is a question which has been asked in the JEE Mains 2019 examination. The next is in transforming 0.01 mole of lead sulfide to lead sulfate, what volume of 10 volume hydrogen peroxide is required? And the choices are 11.2 ml, 22.4, 33.6 and 44.8 ml. A question asked in the West Bengal engineering entrance examination. So this is a question I chose because it is going to use both the reactions as well as what you have learned about the volume strength in the last lecture. So right, so these are the first 3 questions. Question is, consider the reactions H2O2 plus Hi forming I2 plus water, HOCl plus H2O2 forming hydronium ions, chloride ions and oxygen, and which is the following statement is correct for hydrogen peroxide. So it is an oxidizing agent in both A and B. It is an oxidizing agent in A and a reducing agent in B. A reducing agent in A and an oxidizing agent in B, and a reducing agent in both A and B, and an NCERT exemplar question. So I hope now you understand what you have to do, what you have to check. We have been focusing a lot on this, so you should be knowing the correct answer for this. There's a similar question now again in the NCERT exemplar book. Which of the following equation depicts the oxidizing nature of H2O2? And there are 4 reactions that are given, right? So from these reactions, you have to find out in which of these reactions we can see the oxidizing nature of hydrogen peroxide, and NCERT exemplar question. Next question, which of the following equation now depicts the reducing nature of hydrogen peroxide? Again, this should be understandable to you people. So this is the 4 reactions that you have, and you have to choose the reducing nature of hydrogen peroxide. Again, an NCERT exemplar question. Now, even if you do not know these reactions, if you do forget these reactions, then what you should do is something that I've already told you. Right? So now I hope you all are going to get these questions correct. The next we have is Fe plus 3 is reduced to Fe plus 2 by using H2O2 in presence of NaOH, Na2O2 in water, H2O2 in presence of H2SO4, and the last choice Na2O2 in the presence of H2SO4, a JEE Advanced 2015 question. For the decolorization of 1 mole of KMNO4, the moles of H2O2 required are half, 3 by 2, 5 by 2, 7 by 2, and this is the question which has been asked in the AIMS examination for the year 2002. So you can see various questions coming in various competitive examination in advanced as well as mains, even in the AIMS entrance examination, and so many questions in the NCERT exemplar book. So the topic is important, and I hope you now know each and every concept that you have learned in this lecture. So that would be all for this lecture as well as this course. And if you want more courses from us, please do subscribe to the channel if you've not done till now. And also click on the bell icon so that you get a notification the moment we put up the next lecture for you. And there's one information for you all, and the information is that all the questions which we have asked in the lecture review questions, we are putting up 2 lectures for that, explaining all the questions in detail. And the lecture series that we have put is in the crash course hydrogen. This would be helpful for the students when you're going to revise the concepts after you finish your class 12. But for now, when you've just finished this course hydrogen in detail, you want the answers to be explained in detail to you. Well, you can watch the 2 lecture series that we have put up. We'll be just putting up the link for those lectures in the description box below. So see you again. Have a nice day. God bless you.